Merhaba.
Merhaba Mehmet.
Nasılsınız?
İyiyim sağ ol. Sen nasılsın?
İyiyim.
Evet. Hazır mısın?
Evet.
İyi. Hemen böyle 2 dakika bunu bir revise yapalım. Sonra devam edelim. Ondan sonra da belki bir şeye de bakarız. Ee, functions, domain and range.
Hı hı.
Zeros of the function and the critical points increasing and decreasing. Tamam. Yani hepsine bakamayız yani. Yapacak çok iş var ama sadece bir göz atalım. Tamam başladık hadi. Mehmet şunları hemen böyle geçene bakmıştı seninle. Tekrar hemen bakıp bana söyleyebilir misin?
Şey olur.
İlk baştan başlayalım yani. Parent function y equals f of x değil mi? Yes.
Okay. So domain is all real numbers.
All real numbers. Range.
All real numbers.
X-intercepts.
0, 0,
0, 0. Y-intercept.
0, 0,
Extrema points. Points.
0.
None. It
Yeah.
doesn't have any extreme points, right?
Yeah.
It means it's actually a local minimum, local maximum, global maximum, minimum, global maximum. It doesn't have any of this.
Mhm.
Okay, increasing intervals.
None. I mean, wait. Uh, 0 bigger than.
No, no, no. Look, interval means that you can just put your pencil to the leftmost point or end of the graph. When you actually move from left to right, what happens to the function? Now we are here, right? You see, if I
Mhm.
move to the left, I'm here. The function is going up, you see, every time. And now if I move to the right again, here, to the right, here, to the right, what's happening here? It's going up, right?
Yeah, it's rising.
So that's why, what is the increasing interval?
Um.
Minus infinity to infinity. See, last time
Oh,
we did this. You should be able to tell me this quickly. Just increasing interval means that on which interval, when you move from left to right, the function graph is going up. It means this.
mhm.
The value of the function is increasing. Okay, how about decreasing intervals?
None.
We don't have any interval that function goes down. Okay, and behavior?
Um. It was as x goes negative infinity, fx goes to positive infinity.
No, come on, Mehmet, come
Negative,
on. Look,
negative,
if you move to the left, what happens to the function? It's going down, right?
negative, yeah.
Do not yet look at the graph. You don't say that. It's just going down. You see, that means it's negative infinity. Okay.
As
And x goes to positive infinity.
it goes positive infinity.
Very good. F of x goes to positive infinity. Okay. And next one is absolute value function. Domain,
All real numbers.
all real numbers. Let me change to green. All real numbers. Range,
0 bigger than equal to x on a y.
still you're confusing. Why, man? That's range means that the set of y values,
Oh
right?
yeah, y. Yeah,
The domain means that the set of x values. So what is the range of this function?
0 bigger than equal to y.
0?
Um,
0? Y is greater than or equal to 0, Mehmet.
oh,
Why are you guessing, Mehmet? Can't you see that here, the graph, right? You see, we don't have any part below the x-axis. So y values is here, here, here, here, right? If you just pick any point here, for example, if x equals 2, y value is here. If x equals, for example, 4, it is here, right? Or
yeah.
negative 4, again, it is here, right? It means all the time is above the x-axis. That's why y is greater than or equal to 0.
Mm-hmm.
X-intercepts,
0,
the origin, right? And y-intercept, also 0.
0.
And extrema?
None.
Really? But can't you see this range is y is greater than or equal to 0? That means that the function has minimum value, right? That is 0.
Oh.
So extrema is, it has absolute minimum
Oh.
at 0.
Yeah.
Increasing intervals?
Um. It goes to infinity to no negative infinity to infinity.
Really?
Oh no, 0 to infinity.
Increasing interval. If you look at the graph from 0 to infinity, it's going up, right? Always keeps moving up. That's why increasing interval is from 0 to infinity. And how about decreasing interval?
Um. Yeah. Uh. It goes negative infinity to 0.
If you look, for example, move from left to right until origin, right, the function keeps going down, right? It's falling down. Then
Mm-hmm.
from 0, it keeps going up. And that's why decreasing interval is from negative infinity to 0.
Yeah.
And how about the end behavior? What happens as x approaches negative infinity?
As x goes to negative infinity, um, fx
F of x
goes positive.
positive infinity. And as x approaches positive infinity,
It goes negative infinity.
negative.
Oh no, positive.
Are you guessing or you really can see this?
No. Uh. Yeah, it's positive
Now, why positive?
because it's increasing.
Can you show me with your mouse? Can you actually, this um annotation? Why is it decrease? What is it? As f of x, as x approaches positive infinity, f of x approaches positive infinity. Why?
Because it's increasing to the right. Like
Because the graph is going up, right? You see it's rising all the time.
yes.
If you, for example, if it is 2, it is 2. If it is 4, 4, 6, 6, right? As x increases, also y is increasing, which means that the function is increasing.
Mm-hmm.
Okay, next function, next one.
Domain is all real numbers.
No, what is the function here? What is the pattern function?
Oh, fx equals x squared.
F of x equals x squared. Domain,
All real numbers.
all real numbers. Range,
Y bigger than equal to 0.
y is greater than or equal to 0. X-intercepts,
0,
0, 0. Y-intercept,
0, 0.
extrema. What is it?
X,
Absolute maximum, absolute minimum, global minimum, or local maximum, local minimum? What is that?
yes. Absolute minimum
It has absolute minimum, right? Where?
at the 0.
At origin, right? 0, 0. And
Uh-huh.
how about the increasing intervals?
Yeah. When it's negative to infinity.
Mehmet, again, I feel that you're just guessing, you don't understand what's going
Oh
on
no,
here.
0 to infinity.
Yes, 0 to infinity. Look at the part of the graph. If x equals 0 to infinity, as I just keep moving to the right, right? The function's here, and next step here, next step here, next step here, next step here, right? It just keeps moving up. And that's why increasing interval is from 0 to positive infinity. And how about decreasing intervals?
Negative infinity to 0.
Negative infinity to 0. Okay. And behavior,
As x goes to negative infinity,
Mm-hmm.
f of x goes to positive infinity.
Look at the graph. It keeps going up, right? That's why it's getting bigger and bigger, positive infinity. All right. And how about as x approaches positive infinity?
It
F of
goes
x
positive.
approaches positive infinity. Okay. All right. And how about this function?
All real number. Oh wait, that's uh f of x x over 1.
No. What do you mean x over 1, man? But x over 1 means x, right?
Oh wait, x cubed.
You mean 1 over x?
Yeah, 1 over x.
No, 1 over x, it doesn't pass through the origin.
Oh.
So this one is x cubed. Look at the graph. It's x cubed.
Mm.
When it is 0, it is 0, right? 1 over x, x cannot be equal to 0. Okay, what is the domain?
All real numbers.
All real numbers. Range?
All real numbers.
All real numbers. And x-intercept?
0, 0.
0, 0. Y-intercept?
0, 0.
0, 0. Extrema?
Infinity to negative infinity.
Extrema. Extreme points.
Oh, none.
Does it have anything, something like this, or like this, or
No,
like this, or like this?
no.
It doesn't have, right? That's why there's none. Increasing intervals?
0 to infinity.
Again, you start guessing, Mehmet. Just one question. If you draw on the paper, you never get confused. You never do
Oh
anything.
no,
That's why
negative, negative.
you are just guessing. Because if you look at the graph, it's always going up. Can you see that?
Yeah, negative infinity to infinity.
Imagine that, Mehmet, you're walking on this path. Okay, this is your path. And now this x is time, okay? It's changing from left to right. What happens here? Now, at some point here, if you move to the right, now you're here. To the right, now you're here. To the right, now you're here. To the right, now you're here, right? Now to the right again, you're here, right?
Mm-hmm.
Every time the function is increasing, right?
Yeah.
Even if you make a table, you will see that if x, because the function is x cubed, right? If x equals 1, it is 1. If it is 2, 8. If it is 3, 27. If it is 4, 64. If it is 5, 165, right? 125, right? So what's happening
Mm-hmm.
here to the value of the function? Every time it's increasing, right?
Mm-hmm.
Do you understand what I mean?
Yeah. So it goes to negative infinity to infinity.
Yes. I mean, Mehmet, for example, we are talking about this function, right? Let me explain one more time. F of x. Because if you write it down and think, you can understand what we mean by increasing function. Because looking at the graph, it's really easy to determine or identify the function increasing or decreasing. If you make a table, Mehmet, for this function, okay, let's say this one is x and this one is y, right? And suppose that x equals, let's say there's negative 23 or negative 2 or negative 1 or 0 or 1 or 2 or 3, right? So first,
Yeah.
negative 3. So f of negative 3 means that's negative 3 cubed, right? What is
Yeah.
negative 3 cubed?
Negative 3 cube, negative 9.
Negative 27. Cube means that's 3 times 3 times 3, right?
Yeah.
You have to multiply 3 by itself 3 times. That is negative 27. And how about f of negative 2?
F of negative 2, negative 8.
Negative 8. Now I write here negative 8, right? And now if you just keep calculating this, Mehmet, look, negative 1, it is negative 1. 0, 0. 1, 1. 2, it is 8. 3, 27, right? Now, if you
Yeah.
plot these points on the x-axis, what happens? Remember, look, if you this is our x-axis, right? This is our x-axis. right? And this is our y-axis. So
Yeah.
this one is, let's say this -1, -2, -3. And this is 1 and 2 and 3, right? When it is -2, it is 8. 8 is, let's say, this somewhere here. -2, it is here. -1, it is here. 0, it is here. Okay, actually, it's not like this. The graph is something like this. Okay, smooth curve. Okay, it just goes like this.
Mm.
As I move from left to right, the function always increasing here, here, here, here, here, here, here. And that's why I say everywhere the function is increasing when you move from left to right. That's the meaning of, this increasing function or decreasing function. Okay, so increasing interval is from -infinity to infinity. Always this function keeps going up. And how about decreasing interval? None. It never decreases.
Yeah.
And how about the end behavior? As x approaches -infinity, right? F of x approaches what?
Positive.
-infinity. Look, it's going down, right?
Oh.
If you just keep to the left, right, x is decreasing. -2, -3, -4. What happens to the function? It's going down, down, down. And how about as x approaches positive infinity, f of x approaches
Positive.
positive infinity. Okay.
Yeah.
All right. How about this function? See the
The
curve?
current function is fx squared.
Square root of x,
Yeah, square root of x.
right? What is the domain?
Domain is um
Look at the graph. X values.
it rises from 0.
No, the graph is only in the first quadrant, right?
Yeah.
So x is greater than or equal to 0.
Oh yeah.
That's the domain. That means that still, Mehmet, you need to practice some questions yourself, because domain range, looking at the graph, that's very, very easy task. But still, you are thinking because you didn't you know what it is, but you don't have, the confidence in yourself. You're still not sure, is this so or not? You're thinking. Well, what you need is you have knowledge, okay? You just need some more experience. Practice a few more questions. The
Okay.
range, how about the range?
Y bigger than or equal to 0.
Yes, y is greater than or equal to 0. X-intercepts,
0.
origin, right? Y-intercept,
0.
also origin. Extreme values or extreme points,
Um it rises. Wait.
extreme, it's
None.
like,
None. Infinity.
what do you mean by infinity?
Um
Hmm?
Extrema. Um
Extrema means that again, does it have local minimum or local maximum or absolute minimum or absolute maximum? And this function, right, you see here, it just keeps going up, but it has local minimum, right, global maximum or absolute
oh
maximum. So it has absolute minimum at where? At origin, at 0, 0. 0, 0 means that when x equals 0, the function attains its minimum value. That's 0.
oh
And increasing intervals,
uh 0 to infinity.
it is 0 to infinity. How about decreasing intervals?
None.
None. It never goes down, right? And end behavior?
Wait, as x goes to infinity.
No.
Oh, negative.
Look, it's starting from 0, right?
Oh, as x goes to 0, f of x goes infinity.
Really? If x equals 0, what is y?
0.
So why are I saying infinity then?
Oh.
If x approach 0 means that if you get closer and closer to 0, like if x equals 4, it is 2. You see, if x equals 4, it is 2. If x equals 2, square root of 2. If x equals 1, it is 1. If x equals something, as you actually getting closer and closer to 0, we'll look at these heights of these arrows. It's getting shorter and shorter, right?
Mm-hmm.
So that's why f of x gets close to 0.
Yeah.
And how about as x approaches positive infinity,
It goes positive.
f of x actually gets bigger and bigger, right? Okay. Is it enough? And also, let's just see two more, and we'll continue with our examples, okay? And how about this function?
F of x, this is 3x squared, yeah.
Cube root of x. Cube root of x,
Oh.
right? Again, immediately, if you just draw the decimals, you can see it's graph. If you're not sure, we have to draw f of x equals cube root. If I like cube root, it doesn't understand. So 1 over 3. You see this function. When it is 0, it is 0, right? As you move up, right? Here, here, here, right? It's just
Yeah.
going up. As x goes down, you see to the left, here, here, here, here, right? Also decreasing. But when you move from left to right, when -8, it is here, right? When -6, it is here. -4 is here. -2, it is here, right? It's going up, right?
Mm-hmm.
Okay. So what is the domain of this function?
The domain of this function is all real numbers.
All real numbers. Good. Range.
All real numbers.
Very good. X-intercepts.
0,
0, 0. Y-intercept.
0.
0, 0. Origin. Don't say 0, 0, 0. Extrema. Does it have any extreme values?
Yeah.
Really? Where?
Oh, never mind. No.
When I say extreme values, just a second. I see one nice picture. I'll show one more time so that you can understand better. Okay. Now, can you see my screen?
Yeah.
You see this graph? You're moving from A to C. Can you see that?
Mm-hmm.
Now, from A to B, what's happening here? The function is going down, right?
Mm-hmm.
And now this point B, you see it's a minimum point here.
Yeah.
But it's not the smallest point of the function. That's why it's a local minimum. Now, some function keeps going up. Now it's increasing, increasing. Now it reaches some maximum value here at C, you see, local maximum. And after that, it keeps going down again. And now, actually, this point D, you see point D, that is the lowest point. We don't have any point that is lower than this. That's why this absolute minimum.
Yeah.
And again, it just keeps up, right? It's increasing now. The function going up, you see? It's going up. That is the greatest, the highest point of all the points of the function, right? That's absolute maximum.
Yeah.
When we just say that extrema, we means that these points does it have local maximum or local minimum, or absolute maximum or absolute minimum.
Mm-hmm.
Okay, and third, actually, local means that comparing to some points, neighboring points, the point has either the maximum or minimum. And just if you imagine a mountain, that is, the highest points or lowest points. You see, when you
Yeah.
look at the graph, it's really, really easy. What is the concept? And just maybe the words you have never heard before. I don't know. Absolute maximum, absolute minimum, local maximum, local minimum. Extrema means that actually, that's this turning points of the function. Okay. So now if you look at this, does it have extrema? Extrema means that extremum means that extreme points. Does it have
No,
any
it
extreme
doesn't.
points?
No.
No. And how about increasing intervals?
0 to infinity.
No. It's always going up,
Oh,
right? Can you
negative
tell me?
infinity. Negative infinity
Yes.
to negative.
Yes,
I mean,
that's right. It's from negative infinity to positive infinity. Decreasing interval?
no.
None. Because we have already seen that here over the entire real number line, right, is increasing. That means that we don't have any interval that is where the function is decreasing. Okay, how about the end behavior? As x approaches negative infinity, f of x approaches what?
Infinity.
Negative infinity, Mehmet. It's
Oh,
going down, right? You see?
yeah.
So as x approaches positive infinity,
It goes infinity.
f of x again approaches positive infinity. Okay. And the last one. And how about this function? You see, it's not crossing the x-axis.
It's 1/x.
1 over x, right? Immediately we can just see this to visualize. So f of x equals 1 over x. Because x, at 0 is not defined. What means, if you look at the graph, Mehmet, if you just approach 0 from right-hand side, right, it's like 6, x equals 4, x equals 2, x equals 1, x equals 0.1, x equals 0.001. The function graph is going up, right? You see?
Yeah.
So what happens here? That means that as x approaches 0 from right-hand side, the value of the function is going to infinity. That's approaching infinity. And how about if x goes to negative infinity, the function is getting closer and closer to 0, right?
Uh-huh.
And how about the graph? If you approach 0 from left-hand side, see like -4, -2, -1, -0.1, the function going down, you see, falling down. Is going to negative infinity. That's what actually, we call this reading the graph. Can you read the graph? Where it's increasing, where it's decreasing, and blah, blah, blah. So let's put this here. Save this. So the function is f of x is equal to 1 over x. And can you tell me what is its domain?
All real numbers.
Really? I'm just telling you that at 0 it's not defined, right? X cannot be 0.
Uh,
In interval notation,
oh,
because 0 is not the domain point. At 0, the function is not defined, right? You cannot calculate 1 over x when x equals 0,
oh,
right?
yeah.
That's why domain is this. And if they ask you, for example, to do this, to write this in set builder notation, f of x is equal to 1 over x. Set builder notation is domain will be D is the set of all real numbers such that x is not equal to 0.
Oh,
It's a very compact form of actually expressing something, the set form. Here, how do you read this? Domain is equal means is the set, because the curly bracket means the set of such x's where this vertical line is where x is not equal to 0. Any real number but not equal to 0. Okay, let's continue. How about the range?
the range is um, it's negative infinity
Yes, negative infinity to
to 0,
uh-huh.
u 0 to infinity.
Yeah, U means union, right?
Mm-hmm.
Union means or. And does it have any x-intercepts?
No,
No, because not passing through x, right? And also y-intercept? No. And does it have any extreme values?
no,
No, it doesn't have any extreme values. And how about the increasing interval?
yeah,
Where?
Um, 0, no wait, no,
No, right? As here the function, for example, if you move from 0 to positive infinity, every time the function is going down, right?
yeah,
And also if you move from negative infinity to 0, the function is again going down. So we don't have any interval where the function's graph goes up. It is not. And how about decreasing intervals?
no,
Come on, man. If he has no increasing interval, it must have some decreasing interval, right?
oh, in negative infinity to 0.
0 or from 0 to positive infinity. All the intervals of domain points is decreasing,
Yeah,
right? And how about end behavior? As x approaches positive infinity, yes, Mehmet.
as x approaches positive infinity, oh, negative infinity,
Yes, negative infinity. F of x approaches.
will be negative.
Look at the graph, Mehmet. Look at the graph. If you want, I can show this. What happens if function is going? You see, the function is going infinity. What happened? Look at the graph.
It goes infinity to left.
Really? The graph, the y values, is getting closer to 0. You see, it's getting closer to the y equals 0, right?
Oh,
You see, it's getting closer and closer to y-axis, which means that the y value is getting closer to 0. So it's approaching to 0.
oh,
And also, as x approaches, why am I writing x? As x approaches positive infinity, the value of the function is approaching 0 again. You see the graph is getting closer and closer to 0, right?
yeah.
That's it, man. It's not so hard. I don't know why you're still confused. Look at the just graph. What's happening here? The y values. You should understand what we mean by x value, y value. What do we mean by domain and range?
Oh,
All right, let's continue. Okay, now I just stop here and let's talk about domain a little bit. Okay, and last time we talked about transformation. Do you remember these things, Mehmet?
yeah.
If k is greater than 0, if you subtract this from the whole function, the graph shifts down, translates down, right? If you're adding, it shifts up. If you're adding something to the x value, right, it's shifting to the left, subtracting to the right. And reflection above the x-axis, you're multiplying the whole function by -1. And above the y-axis, the input value by -1. And vertical compression, vertical stretch, horizontal compression, horizontal stretch. And we did these questions. Let's say a few questions, and after that, we will see. Okay. Now, can you just tell me quickly what's happening in question 10? Do you remember? First, Mehmet, can you tell me how many transformations are performed on this function, on this pattern function? What is a pattern function?
Parent function is x cubed.
Right? So pattern function is pattern function. It is f of x. So that's equal to x cubed. Okay. The first one, let me just tell you. Tell me, what does that negative plus 3 stand for here? You know, x plus 3.
It goes to left.
Left, right? Translation,
Left 3.
left 3, right? And
Mm-hmm.
how about the second transformation? How about -8?
It goes down.
Down. Very good. Translation, right? Translation, down 8. And how about negative? Because we have negative sign, right? That means -1.
It is reflection.
Reflection, because you are multiplying the whole function. Immediately, just imagine, Mehmet, if it is 3, right, y, it becomes -3. So that is reflection about over the
The
x-axis, right?
yeah,
Over the x-axis. And how about 3 over 2?
3/2.
You're multiplying the whole function by 3 over 2, which is 3 over 2 is greater than 1, right?
Horizontal.
No. Look, if you multiply the whole function by a number, k times f of x, it is less than 1, right? Greater than 1, k equals f of x. What is that?
Stretch.
Stretch. This vertical stretch, right? So that
Mm-hmm.
is vertical stretch by k equals 3 over 2.
Mm-hmm.
Okay, that's it. And also we were doing some equations. Okay, this one is greatest value function. You told me that you didn't see this. That's why I skip for now. Okay, this is the homework. Okay, Mehmet, let's just do 2 questions, and after that, I want to talk with you about piecewise different function. And if you have more time, we will see. Okay, let's just do one more question and move on to the question. I mean, to piecewise different function. What is a pattern function? This question 14.
X cube
Really?
plus square, I think.
Hmm? X to the power of 1 over 3, right?
Oh,
That means that cube root of x.
yeah.
You remember this function? X to the power of 1 over 3,
Oh,
right? Cube root of x. That's x to the power of 1 over 3. That means cube root of x. Okay. And how about reflect in the x, y axis and translate 4 units right?
um,
First, reflect in the y axis.
it will
And what is
be
that? Reflect in the y axis.
um x plus no -4.
Okay, I don't know this. Let me just write my hands. So reflect in the y-axis, Mehmet. We multiply the input value by negative, right? X minus x, right? That's reflecting about the y-axis. So f of x, and after translate 4 units right, right?
Equals to minus.
First, we have cube root of x, 3, right? Reflect in the y-axis, so that is minus x, and translate 4 units right. Okay, I'm just changing this x, 4 units right. That is plus 4.
Oh,
Okay, because to reflect about the y-axis, we should multiply input value by -1. And to shift, right, translate 4 units right, I need to add something to the input value. You see, like, for example, this one, right? If I reflect this about the y-axis, what happens here? F of x equals, here I have negative x now to the power of 1 over 3. Can you see the reflection about the y-axis?
yeah.
And after that, I want to shift this 4 units to the right, right? So I need to add to this function, you see, in parentheses, plus 4 is to the right.
It's supposed to be minus.
Oh, minus, right? Minus to the right, minus. You're right. So it is minus. Minus. The same function, right? Just move 4 units to the right.
Mm-hmm.
Okay. And next one is another example. Horizontally compress by a factor of 1 over 2 and translate 5 units down.
Um, so it will be
First, compress by a factor of 1 over 2. So that is cube root of, right? by a factor of 1 over 2, that is 2 times x.
Oh,
When it's
yeah.
horizontally, if it's 1 over 2, you should multiply by 2. If it is 2, you should multiply by 1 over 2. And translate 5 units down, that is minus 5, right?
Mm-hmm. Yeah.
Okay. And this question 15 and 16, a little bit challenging question. If you could do these questions, it would be really great. You want to try this? Can you read question 15?
If the function is f of x equals 2, parentheses x minus 5, parentheses square plus 3 is reflected across the y-axis, then translate right 6 units and down 2 units. Write the equation of the new function.
Do you think you can do that? I like Mehmet. First, can you just tell me this thing only? Let's just do here. Question 15. Okay. Suppose our function is y is equal to f of x. All right. The first transformation. Let me just write here first transformation. What is that? Reflected across the y-axis. So what should I write here? Y is equal to what?
Y is equal to parentheses x.
No, just look at this f of x, reflection above the
Oh, negative,
y-axis.
negative, negative.
Yes, f of minus x, right?
Yeah.
Okay, the second one, read the second transformation.
Well, what do you mean? Which one? Then translate right 6 units and down
Yeah,
2 units.
that's the first transformation. That's the second one, right? So now it's translated right 6 units. So that's y is equal to what?
Negative 6.
F of minus to the right, right? So I need to add to x. X minus 6, right?
Yeah.
And how about the third one?
Um, down 2 units.
Yes.
Negative 2.
Y is equal to f minus x minus 6, right? Down minus 2.
Yeah.
Now, what is the equation like? Can you tell me what is the equation? This f of x equals 2 times x minus 5 squared plus 3 becomes what equation after these transformations?
Um, what do you mean?
We are talking about this function, right?
Yeah.
So now, after these transformations, our function f of x, this f of x becomes this function, right? This equation. So can you write this equation in x?
In x,
What is the equation here? The equation of the new function after this transformation.
y equals f parentheses negative parentheses x minus 6 minus 2.
Now, what is that? Can you calculate and tell me your final answer? I mean that I think you didn't get the question. That's why I'm saying trying to explain this. That's a bit challenging question. A lot of students, they may struggle to understand this. And now after this transformation, if I just simplify this, my function becomes f minus times x, it is minus x, minus minus, it is plus
Plus 6
6 minus
plus
2,
2.
right?
Oh,
And what is my original function? 2 times x minus 5 squared plus 3. And
yeah.
now our input value is negative x plus 6. Can you see that?
Yeah.
Yeah, I know you're tired, but just 10 more minutes, Mehmet. And now instead of x, I'm going to substitute this minus x plus 6. That's our input value now. Okay. So here we have 2 times, wherever I see x, I will put negative x plus 6. So x, that's the input value. So that is negative x plus 6. And now here we have minus 5, right? And the plus, I have 3 here. The whole thing is equal to f of minus x plus 6. And plus in the function, right? Here we have minus 2. Here we have minus 2. And that thing, this function, is equal to f of minus x plus 6. If you simplify this, I have also square here, right? 2 times minus x plus 1 squared plus 1.
Oh,
And this shows your algebraic manipulation skill. Can you just write the function after the transformation? What kind of function will we have here? Okay. All right. This question 16 also very beautiful function, but you can give it a try if you are interested. This is homework. Let's talk about piecewise defined function. You told me that also you studied piecewise defined function, right?
yeah.
Okay. And also, I actually suggest you to watch a very short video, maybe 5 or 7 minutes, about piecewise defined function to get some idea. And in this way, we can learn much, much better. Mehmet, what is piecewise defined function? It means that from the name, as it suggests, okay, a function which is defined piece by piece over different intervals. That's the meaning of piecewise defined function. Okay, once again, what is piecewise defined function or piecewise function? Simply, it's a function where it is defined piece by piece, okay, over different intervals. All right, like if you look at this example, also last time we worked on this, if you remember. F of x, I'm saying that that's equal to 2 times absolute value of x minus 5 if x is less than negative 1, negative 3, right? So that means that if our x is all the way until here, right? And this one is, what is it? Negative 3. Our function defined differently. And how about from negative 3 to 7? And this one is negative 3 to 7 and not inclusive, is defined differently again, like minus x squared plus 4x. And if our function is greater than or equal to 7, so greater than or equal to 7, right, it is different. Now, if I just draw my number line, this is x-axis. So this point is, what is it? It is negative 3. This point is 7, right? Over different intervals, the function is defined differently. Okay. And one example, if you ask me, I would expect this question. Okay, where do we use this? How important it is? Okay.
Oh, yeah.
Huh?
Nothing.
Just one example is, let's say you're going to pay tax, right, at the end of each year, right? And tax is calculated based on your income, right? For example,
Yeah.
if your income is, let's say, under 75,000, you pay at different rates. If it is between 75,000 and 125,000, you pay different tax rates.
Yeah.
If it is above 125,000, you pay different rate, right? So that
Yeah.
means that now the government says that if your salary is between zero, income is between 0 and 75,000, okay, and we have one function. And between 75 and 125,000, you're there using different function. And greater than 125,000, they use different function. That is one application of piecewise defined function in application in real life situation. Another example, for example, let's say, and you are going to, for example, every month we pay for electricity, right? And also usually electric companies, okay, they use this piecewise defined function to charge I don't know, this, to calculate the cost of electricity usage.
Yeah.
For example, if they say that if your usage, monthly usage is under 1,000, you have to pay 15 cents per kilowatts. And between 1,000 and 2,000, let's say you have to pay 17 cents. If you use more than 2,000 kilowatt per month, then you have to pay 23 cents. So that in this way, they encourage people not to waste electricity, right?
Yeah.
Because in this kind of situations, actually, what is it? Piecewise defined functions are used.
Yeah.
Now, if you tell me, look, first the calculation, if the piecewise defined function is given, number one, how do we calculate its value? Now, can you tell me, Mehmet, for f of -5, the first one, f of -5, to calculate the value of the function at this point, which function I use here? The first one, the second one, or the third one?
The first one.
Is the first one, right? Because -5 is on the interval where it falls on the first one, right? It's somewhere here, right?
Mm-hmm.
And that's why I need to use the first function then. So it will be 2 times absolute value, -5 minus 5 equals 2 times -5 minus 5,
Plus 10.
-10, and absolute value is plus 10, which is equal to 20, right?
Yeah.
And how about B, f of, let's say this 2. So this one, which function do we use for this calculation?
The third one.
Second one, right?
Oh, the second one?
Because 2 is somewhere between between -3 and 7, right? Somewhere here, right?
Mm-hmm.
So that's why we need to use the second one. So minus 2 squared plus 4 times 2. Negative times 2 squared, that is -4 plus 8. So the value of the function is 4. And the last one, C, and how about f of, what is that?
7.
It is 7. As you see here, 7 belongs to here, right? This point. It's on the third one. So I need to use the third function, square root of 2 times 7 plus 6. 2 times 7 is 14. 14 plus 6 is 20. So the value of the function is square root of 20.
Mm-hmm. Oh, yeah.
That's how we calculate, because you need to identify, the functions where, on which interval, which function is defined.
Wait, can you go back? Let me, uh, okay. Okay,
Okay.
yeah, yeah.
All right. And for graphing, I don't know, should I show this or not?
Yeah,
Because,
we did not learn that. Yeah.
okay. Uh, for domain and range, let's do 2 questions, Mehmet. Then we'll finish the class, okay? Let me just ask you 2 questions, how much you can remember. Domain and range. Where's your homework? Here. It says that here, what is the question? Give the domain and range of graphs 4, 5, 6 in set notation. Okay, and graphs 7, 8, and 9 in interval notation. Determine whether each relation is a function. Okay, now we are talking about 7, 8, 9. So we are going to give the domain and range in interval notation. Now look at question 7. Okay, let's do 7, 8, 9 and finish the class. And 7, what is the domain of this relation?
Um, 5 and -5.
-5? Domain.
No,
Domain is x values, right?
yeah. Oh no, it's 2. No, -3, -3.
-3. Inclusive or not inclusive?
Inclusive.
Inclusive, right? You see, I can touch the point if I draw the perpendicular line. So it is from -3. My gosh, it's so sick. So there's -3 to
-3 to infinity.
oh, mama, still you don't get it. I don't know how can I teach you this. Why we learn a lot of examples, still you don't get it,
Oh,
Mehmet.
to 0.
5, look at this. X is changing from this point till this point, right?
Oh,
If you take this point, for example, you go up or down, we don't hit any part of the graph. If you take any point here, go up or down, we don't meet any part of the graph, right? But here, I can see the graph, you see? I can meet the graph here if you take any point. If you take any point here, here, right?
Uh-huh.
Why say you don't get it, man? A domain is very simple thing. Why you get confused so much?
Um,
It is just 5. And how about the range? The lowest point and the highest point, right? The lowest point is, as see here, this point. We don't have any graph below this. 1, 2, 3, 4,
A4.
negative 4. 1, 2, 3, 4. It is 4. That is the range of this function.
Oh,
After we did like 50 questions, still you get confused. I don't understand why. It's very basic thing, Mehmet. And how about the function? Is it function or maybe you're tired? I don't know. Is it function or not?
yeah.
No,
Oh,
because it fails the vertical line test. If you draw the vertical line, it crosses at 2 points, right? That's why it's not a function.
oh.
And how about the second one? What is the domain of this function and the relation?
The domain, uh, -3.
Look at the
Oh,
graph. It's going to negative infinity to the right-hand side, positive infinity. It never stops. So x values is all the real numbers. And how about the range? Minimum value is here. It is turning. Maximum value is here. So 1, 2, 3. It is from -3 and 1, 2, 3, positive 3. Is it a function? Yes, because it passes vertical line test. If you draw any vertical line, there will be only one intersection point.
oh,
And how about here, D? The domain, again, it goes up or down. Only we have one hole. That's not the domain point. So domain is from negative infinity to -1, not inclusive, -1 to positive infinity. And how about the range? This point is, we don't have such point. 1, 2, 3, 4. So that is negative infinity to -4 or -4 to positive infinity. Is it a function? Yes, because if you draw any vertical line, it passes through only one point. That's why it is a graph of a function.
oh.
You should think, Mehmet, I suggest you, maybe it takes time a little bit. Now you're like, are you 14 years old now or 15?
14.
You were born in 2010, right? Or 9?
9.
9, Mehmet. But I'm just waiting to change. You need to change, okay? Because I teach, again, you forget. I teach, again, you forget. But the reason is you need to practice a little question, Mehmet. Everything is okay, but just one piece is missing in this puzzle. You need to do some independent work. It is hard, but believe me, once you change your habit a little bit, you will see a lot of improvements. And also, you will enjoy your life a lot.
Okay.
Okay, just a little bit, okay, because still you get confused. That means that you're not doing some independent work. Mehmet, I wish you good luck, okay, for tomorrow. And next week, we're going to meet on Wednesday, right?
Mm-hmm.
And Saturday, let's see. Right now, let's say Saturday, 10 o'clock, but I'm thinking to have class at school from 8 to 12. If we can arrange, we can do after 12, okay? But I will let you know, all
Okay.
right?
Saturday,
So,
Sunday too.
yeah, so Wednesday, Saturday, Sunday. Okay, Sunday, no problem.
Okay.
All right. Let me see you. Okay, in the exam, don't rush. Think. Try to remember how we learn. Okay. See you
Mm-hmm.
next week. Okay.
Bye bye.
Yeah. Bye bye.